In this video, we're going to talk about finding the limits of polynomials. So in the past, I've given you a whole set of laws on limits. So hopefully these laws seem familiar to you. I want to draw your attention to this law here. What this law here is saying is that to find out the limit of this complicated function here, just concentrate on finding out the limit of one function, which is this one here, and then find the limit of the other function, and then multiply the two together. That will give you the limit of this whole thing here. So what this is saying here is, when you have something complicated here, rather than trying to find out the limit of this complicated thing here, just concentrate on finding out the limit of this, and then on a separate occasion, concentrate on finding out the limit of this. And once you've got the two limits, multiply them together. That will then be the same as you finding out the limit of the complicated function. Okay, so that's what this law is saying. Rather than trying to find out the complicated function here, you would just concentrate on finding out this, the simpler version, and then find out the limit of this one, and then multiply the two together. That will be the same as you finding out the limit of this complicated thing here. Okay, so now we can use this law here to help us with this. Hang on. So if I were to give you if I were to ask you, find the limit of x squared when x approaches a here. Well, this thing here, you can visualize it as one function multiplying a function. So x squared, I can break x squared up as two functions. Well, the two functions are actually the same. So here I can visualize x squared as, so this here is one function, this here is another function which happens to be the same. So I'm just using this law here. So I can break this up as, well, I can visualize this as x times x. So rather than finding out x squared, I could just find out the limit of x and then the limit of x. So it's just me finding out the limit of this and then the limit of this. Okay, so hang on. So if you're given find the limit of x squared, you can visualize it as one function here, and then by using this law here, you can well, this law is saying, well, work out the limit of f of x, work out the limit of the second function. So I'm just saying, work out the limit of the first function, which is this one here, and then work out the limit of the second one, and then multiply the two together. That will be the same as you finding out the limit of x squared. Well, anyway, the limit of this here, as x approaches a, will be a. Okay, so whenever you see this here, it's like, well, whenever you see this here, visualize the function y. Well, you can imagine as y equals x here. This is your function here, y equals x, and then a is here. So as x approaches a, well, this limit here will be a. Okay, I've done several videos on this. The limit of this here will also be a. So the limit of x squared is really a times a, which is a squared. The point that I'm trying to make here is that when you're given, in a way, a polynomial here, you can just simply put the a into here, and, well, it's the same thing here. Well, anyway, let me give you another example. So here, find the limit of x to the power of 3 or x cubed as x approaches a. So you can use the law here, rather than, well, you can visualize x to the power of 3 as one function times another, which happen, well, they're all the same function. So here, you can find out the limit of this times the answer to this times the answer to this. Well, the limit of this here is a, the limit of this here is a, this here is a. So you can simply just put a into here. So that will be a to the power of 3. So the limit of x to the power of 3 as x approaches a will just simply be this. So when you're given something like this, hang on. So when you're given a polynomial like this here, as x approaches, let's just say it could be anything. Let's just say it's 5. well, you can visualize this whole thing. Well, you can visualize this whole thing here as a limit of this. So that's this bit here, and then plus it with the limit of this part here, and then plus it with this. And by the way, the limit of 7. Well, you can visualize this as a graph of y equals 7. So when you approach, let's say A here, it will always be 7. Okay, just remember that. This here will always be well. The limit of this as x approaches whatever for the 7 here will be 7. Okay. Well, anyway, this whole thing here will be this thing here. And then well, my point is that you when it comes to polynomials, you can just simply put the 5 into here, put the 5 into here, and put the 5 into here, because this thing here, it doesn't break down. It's not in the case of where you have something like this, 1 over x, where if x approaches 0, you're going to have 1 over 0. This thing here breaks down. But when it comes to this here, nothing really breaks down. So you can just simply put it straight into there. Nothing breaks down. So well, if you're finding out the limit of this here, you can just simply put the 5 into here, because nothing really breaks down. So the limit of this is really all of these added together. Okay.